And I'm happy to be here, and I'm having a strange topic today, right? So now you wonder what the hell this is all about. So this actually started this summer when I was out playing golf with Emil, and he started to ask me some questions about the challenges that we were facing when we wanted to break in as a, say, ROADM supplier in a fairly mature market. So what I'm going to try to do here is to give you an understanding and some background around that. So basically similar to what Sunet just did, but from a different angle, from a supplier angle. And one thing that I typically get complaints about internally is that I use way too many technical slides. So in this presentation, I've tried to use pictures only, and I've kind of gone a little bit bananas around it. But anyway, what I'm going to talk about here now, is the evolution that we as a company have done. So Smartoptics was founded already in 2006. We did optics and optics only for a decade. Third-party optics, both for, standard routers or compatible optics, but also, Brocade certified optics for the fiber channel space. So what did the market on the DWM supplier side look like about 12 years ago? Well, it was a lot of harmony in the sea there, with big and small-sized fishes and medium-sized fishes, or suppliers working together to serve a market where you had multiple different different requirements and expectation on your supplier. Then about 10 years ago, something happened, illustrated by this, consolidation on the market. So basically, all the mid-sized players got acquired over a period of just a couple of years. Transmode, where I came from, Cyan, BTI, and so on, they all got acquired. And I think this picture very well illustrates that. So the bottom one there, this is an AI-generated picture. Is that? The one at the bottom left there, that's Transmode, and the one above is Corient, eaten by the red guy there, that's Infinera. And that's now about to be eaten by Nokia. So isn't this a great way to illustrate what the market has looked like? Of course, what we did then at Smartoptics, that we saw an opportunity in the market to become the next mid-sized player. So there was a clear gap in the market. And that gap is still a very vital part of our business strategy. So that's something that we're talking about all the time, both internally and with investors. However, what then happened was that it was just less than a handful of large suppliers left. So we were going to go out and compete with them. And that's, of course, coming with several challenges, where we, as a newly established company, need to be able to, differentiate and find new ways of being competitive. So that's basically what I'm going to talk about here, the challenges for a challenger. The 4 bullet points that I've decided to bring up here is related to the building practice, technology selection, API and data models, and last but not least, software and automation. So starting on the building practice, if we now look back here, this is 7-8 years ago, 2017, 2018. It was, primarily in the DWM space, chassis-based solutions with slot-in cards and so on for the different modules. The hyperscaler had changed their way of building stuff and started to build disaggregated. So we wanted to differentiate and build our solution around open and disaggregated building concept. With this, we saw the opportunity to differentiate, but also there were a number of challenges that we knew that we were going to face with this. If we start with the disaggregated part there, compared to having a chassis-based solution, we wanted to make it, build as you grow. And disaggregation can be done in many different levels. So that was the first challenge. How do we disaggregate? To what level? Listening to the different industry initiatives at the time, there were people asking or requesting or thought that you should disaggregate down to, complete disaggregation, basically buying the optical components individually one by one. Amplifier from one supplier, WSS from another supplier. We never really believed in that and wanted to disaggregate on a per degree level or a per, segment level. So we went with a purpose-built, pizza box approach, where each direction has everything you need for one direction. So that's kind of the way that we standardize on. And that, of course, came with some other challenges. If you look at what it looks like if you have a chassis, you have a control unit, or maybe a redundant control unit that you slot into your chassis. That one will coordinate all the configuration and all the different, say, alarm correlation and so on. In this case now, we wanted to solve that problem in an efficient way. Our first approach to this, here we failed miserably, I have to say, looking back in the rear mirror. We wanted to do this in what we thought was in a smart way. So we built on the software side a cluster architecture where one of the boxes could take the role as a master. That one got all the configuration distributed out to the different direction of the boxes. This was, of course, a good solution from a density point of view, no additional boxes. However, we quite quickly realized that the CPU constraint in the ROADMs can be a bottleneck that would require the customer to basically do a forklift upgrade of their entire network. So we decided to disaggregate the control plane with the optical plane and build what we call a shelf controller, so you could then use that as a disaggregated control unit. Then you can build it in a similar way that you did in a chassis-based solution, but now you slot in, of course, then what I say, disaggregated boxes. So this is the challenges that we had with the disaggregated piece. On the open side there, then actually it was not a big challenge. It was more, say, a strategical choice that we did. We wanted to build what we called a true open line system, meaning that we did not want to have any, say, not even talk about alien wavelengths, no capacity license, nothing like that. That's, of course, been something that our customer very much appreciate, to be able to run our wavelength or someone else's wavelength without any cost or complication around it. However, this has been more of a challenge from a commercial point of view, or maybe more in the finance industry. They like to see recurring revenue, they like to see software revenue. That values the company higher. So it's been more of a challenge with the board that pushes us to try to go in that direction. That is not the strategy of the company, however. So those were the challenges that we had around building practices. Going to the next challenge around technology selection. So here, in order to build a solution that our customers wanted, we actually started this journey with a pre-study that we did together with two of the service providers in Sweden. RISE IKEA was part of that project as well, and it was partly financed by Vinnova at the time, where we tried to determine what kind of requirements and what kind of, say, dream box would an operator like to see if we go this route for an open, disaggregated ROADM solution. So that was the background and laying the ground for it. We can quite easily build a high-end and high-performance solution. If we take the most expensive amplifier, the most expensive of everything, we build it with full CDCF capabilities from day one. However, then we don't check the cost box. And in order to differentiate and break in, we have to make sure that we are cost conscious, and we need to find a kind of a niche in the market where very few others have focused. So we started this to look into the different open initiatives, and the most mature from a hardware point of view was the Open ROADM initiative. They were specifying a Ferrari. We, being a Swedish company, wanted to do more of a Saab, reliable, innovative, but not coming with the same cost as a Ferrari, but pretty cool still. So we went for more of a, say, slightly lighter hardware design with a little bit less performance and a little bit less flexibility, optimized to be able to run IPU with DWDM. So you could run even the -10 dBm TX Power 400 gig optics directly over the line system, focusing primarily on the metro space, because that was kind of an area that we saw that there were very few that had gone into that. Mainly the big suppliers took their big boxes and tried to just retrofit that into the metros. So that was something that we started with. We did realize that if this becomes successful, we will probably have to grow and change that and add to that portfolio. And since then, we've also added more, say, capable boxes that is more suitable for kind of regional and long-haul networks. So we have now a more complete portfolio around that. But this was something that we really wanted to get right from the beginning, because it is expensive to redo everything once you have failed. So I think we have done a pretty good job, but of course there is always going to be features and functionalities and requirements that you cannot fulfill when you try to break in and come in as a new supplier. So that was the second one. So looking at the third one, we have this confusing guy looking at his computer thinking about open data models. So how hard could it be? You want to build a new solution from scratch and use APIs and data models that are open. Well, the problem with that is when we started to look into it, very similar experiences that you heard from the Sunet guys, is that it's difficult to find something open that is actually working as you wish. And what is open, if we start there are a number of different, in this case now, data models. I shouldn't necessarily call these data models, but different open initiatives. You have the Open Config, the Open RODAM, ONF TAPI, etc. They all have their own data models. And in each and one of those data models, you can use one or different protocols. I mean, like GNMI, NetConf, RESTconf. And in certain of those open initiatives, you are, say, obligated or recommended to use certain combination. And then, of course, for each protocol, you can also code your data. The encoding can be done differently. It can be XML, JSON, protobuf, for example. So text files or binary files, depending on how you want to have that encoded. So that combination makes it quite tricky to select a solution. And for us as a vendor, we, of course, want to be able to serve as many customers as possible. So how do we go about to do this? The route we selected to go here was to use an open source controller that we could get that was based on the Transport PCE that is part of the Open RODAM initiative. We have, however, realized that we cannot rely on that only because we cannot scale with that and we cannot fit into every environment. So we have to use, a version of that we can evolve to add support for additional protocols. For example, ONF TAPI northbound of the controller, southbound it will be GNMI streaming, and it will be, of course, then different type of NetConf, RESTconf interfaces as well. So we need to build a platform on our control plane or in the controller that can support all the different flavors. We don't have support for all of those today, but it's something that we're working on, and we try to get the majority of them covered. So this has been a way more complicated journey than I expected when we started this, because, I mean, there were a lot of different open initiatives, but unfortunately they all have different ideas what to use. If you were to start a new, say, initiative today, I mean, I certainly have my favorite on how I would select to go about this, but you need to take into consideration all the old equipment out there as well. So it's quite complicated to get this right. So that guy actually is right to be confused up there because it is rather confusing to try to get this right. So that's kind of the pieces that we were struggling with here. And then looking at kind of the last part of this is related to the software and automation. So here we, of course, we need, in order to be, the challenge here is that we were going to try to go up and be competing against the big guys. They have a very mature software. They have a very feature-rich software. We cannot be competitive if we don't have that kind of functionality as well. So how do you go about to do that? We need a planner to do network planning, and we need a management solution to lie on top of that controller. Well, the easiest thing was just to find some open source stuff that we can use and quickly adapt to get our look and feel. On the manager side, that turned out to be quite a bit of a challenge, because when you start to look into it, everyone that has started to develop one of those, if they become successful, they make a commercial model out of it. Makes perfectly sense, but it was very difficult to find something that could be used for this community in an open way. So the solution that we ended up going with was to develop our own management solution for kind of the graphical user interface, to do the point-and-click provisioning and all that kind of good stuff, and FCAPs, etc. So that was something that we needed to do with engineering and develop that stuff. I'll come back to that soon. On the planning piece, on the other hand, then it was actually a little bit better, because the TIP initiative had developed what they call the GMPY, which is a open source Python-based simulation engine that simulates both OSNR and GSNR, so you can get a very, very good optical performance simulation across multi-vendors. So we decided to use that, and it's been turning out to work very, very efficiently. So that piece, the entire path competition in the controller together with that piece probably saved us 20 man-years of engineering. So using those open source pieces have really, really helped us to speed up the development. Another good thing to develop a product from scratch is that you don't have any legacy equipment to support. So you can focus everything on just adding new features, functionalities, and no one working on the retrofitting the old shit to fit into your new model. So that's a pleasure being a new one. But another challenge around this was that when we now want to do an open, say, open and disaggregated building concept, we don't expect that everyone buys everything from us. We hope that they do, but most likely they will buy bits and pieces from other supplier. A typical example that has been, say, to a certain extent, limit the build out from the service providers on IP over DWDM is the end-to-end visibility. You want to be able to see optical performance from your router port all across your optical network. So we needed to have a software architecture where we could also take in, work as an orchestrator, take in data from the optical information from the router ports. So we've been looking quite a bit at the TIP initiative and on how they are, say, recommending to use this based on their mantra model and also in some of the use cases from the MUST initiative. So we've looked at that and tried to take ideas and say, steal stuff from that. And that's really been helping us to kind of expedite that, the correct design. However, the job has to be done. We need to add support for those models. We also long-term want to be able to manage other vendors' equipment through that management system. So we have to take that into consideration as well when we did the design of this architecture. And we are right now in the process of adding support for simulating across multi-vendor network, where you can add a data model from someone else, from some of our competitors into our tool, and with that simulate optical performance across multi-domain networks. So that was kind of some of the challenges that we have been facing. Surprisingly enough, I'm running fast on time, but I guess I'm between you and a cup of coffee, I guess. But so basically, if I summarize this, this has been a extremely fun and exciting, but to a certain extent bumpy ride. If you have questions or want to come and see where we are today, please feel free to come and see us. And then I wish you all a great day and a pleasant evening. Thank you.
Thank you, Ken.